Hello everyone, welcome again. So today's lesson will be on the chemical earth module in year 11 chemistry. And in today's lesson we're going to look at physical and chemical change, and this whole series actually will be focused on the physical and chemical changes. Okay, so our first topic for today is physical and chemical changes. And so we're going to look at what is a physical change and what is a chemical change, and how do they differ, and how do we identify when one is happening and when the other is happening. Okay, so on the left you see the ice block melting, and on the right we have fireworks. Okay, now fireworks are a chemical reaction, whereas ice melting is a physical change. So we're going to see why they're different and how do we actually figure that out for ourselves. Okay, so firstly, physical changes. Remember, it's the ice melting. Physical changes are changes to substances that don't involve changing the physical composition. Okay, so what does that mean? Well, when you melt ice, nothing's actually changed chemically. You've still got water that was a solid, now it's a liquid. Okay, so if you want to do a physical change, you can't change what that substance is made out of. So if I could somehow magically change the water into gold, that would be a chemical change, because I've changed that water in the ice into a new substance, which we'll call gold. Okay, so just because it's melting, even though it looks sort of like a kind of reaction, all that's happening is that the water molecules are freer to move, and so they'll become a liquid. Okay, so the composition of that ice hasn't changed. Its chemical composition is exactly the same. So the physical changes that we commonly see are changes of state. So as you can see here, ice melting into water and then water turning into gas. That would be a physical change. All three of them are physical changes. And obviously the reverse processes are physical changes as well. So, gas condensing into a liquid, then turning into a solid. All of those are physical changes as well. Changes of density. Okay, that's under the assumption that there's no chemical change. So if there's no chemical reactions going on, but for instance, if I took a syringe of air, for instance, and I put a stopper on one end, and I push the plunger down, the gas would start to compress and it would become more dense, but the chemicals haven't changed, so it remains the same chemical. So, but all that's changed is the density. So that could also be a physical change. The dissolution of a solid. So if I took some salt, sodium chloride, put it in water and dissolve it, I could get it back as salt. All I have to do is remove the water. So that's also a physical change. Now, physical changes in terms of what actually is happening in a physical change, well, what we're doing is we're influencing the bonds between particles, not the bonds within particles. Okay, so let's draw a really big water molecule. There's our oxygen, and there's our two hydrogens. Okay, now the bonds inside the molecule are here, which I will circle in red. So these are the bonds inside the molecule. Okay, now if I had another molecule over here, there would be some kind of interaction between the two. Okay, now physical changes only influence this bond between the two molecules, not these bonds inside the molecules. Okay, and that's the physical representation of what's actually happening in a chemical change. Okay, so it's the bonds between particles, not the bonds inside the particles. Okay, and because we're only influencing those between molecules, the bonds between molecules, it makes these changes very easy to reverse. So I can easily turn water into steam and then steam back into water. I can easily turn sodium chloride into sodium chloride solution, then back to sodium chloride crystal. Okay, so they're very easy to reverse. Okay, now in contrast, we have chemical changes. Now chemical changes involve altering the chemical composition of the reactants in the system. Okay, so while physical changes only affected just the state or the way the molecules were arranged, chemical changes actually influence the bonds inside each particle. Okay, And so we're actually rearranging bonds in the particle rather than just rearranging particles. Now, typical signs, so when we see a chemical change, remembering that it's now affecting the bonds between the molecules rather than the bonds inside the molecules rather than the bonds between the molecules. What we'll see is when we do a chemical change, we'll often see the evolution of a gas. So a new gas will be formed, and we'll talk about how we define what a new gas is during the reaction. Often we could get a precipitate. So that's how we know if we have two liquids, two complete liquids, and then we pour them together and all of a sudden a solid comes out. So a solid magically appears in these two liquids. Then we know we've got some kind of reaction, because obviously something's happened to get a solid. The absorption or release of a significant amount of heat or light. So we're talking about, combustion. Combustion is a reaction, and it gives off a lot of heat and light. So that's obviously a chemical reaction. Change in color. So if something changes from one color to another, we know a chemical reaction has happened. So universal indicator, which detects pH changes, is a really obvious example of that. Other ones would include things like hemoglobin. Hemoglobin, the stuff in your blood for biology students. If you expose hemoglobin to air, it turns red. Oxygen. Now, if it's not exposed to oxygen, if there's no oxygen around, it's blue. So that's why your veins are blue, because it's full of blue liquid. Whereas when you cut yourself, it's red, because as soon as you cut yourself, the blood is exposed to oxygen, and so it becomes red. So that's a change in color that you can instantly see. Now, chemical changes involve the breaking of bonds within particles. So as I mentioned before, now we're talking about inside the actual particle. There are bonds, and we're rearranging those bonds to suit our chemical reaction. Now, because we're dealing with those very strong intramolecular forces, that's right, intra, it makes chemical changes very difficult to reverse. So think about burning hydrogen and oxygen. If you burn hydrogen and oxygen, you get, very high burning speed, and it works well for some cars and things like that. But you get water out. Now, how hard is it to turn water back into hydrogen? Okay, and if you think about that, that instantly tells you, oh, okay, yeah, chemical changes are a little bit harder to reverse than just turning ice into liquid water again. Similarly, if you just think of our big global crisis, climate change, CO2 came from burning fuel, and CO2, why don't we just use a chemical process and turn CO2 back into something else? And obviously, here's your answer. Chemical changes are difficult to reverse, so it's hard to change that CO2 back into like a fuel or something useful. Okay? So that's that. So that concludes today's lesson on chemical and physical changes. We looked at what identifies one from the other, and we looked at how to actually identify a chemical change and what are we actually looking for. Okay, so we'll move on to the question segment now, and hopefully you'll learn something from the questions that maybe you missed in this lesson. Okay. So question 1, explain the difference between a physical change and a chemical change, and give examples. Well, a physical change does not produce new substances. So a physical change just retains the original substance that you had. So when freezing liquid water to ice, the first substance is H2O, and ice is also made of H2O, so nothing's changed. In a chemical change, the substance is actually changed and no longer exists. So for instance, the substance composition is now different from when it started. So in burning coal, carbon, C, is changed into CO and CO2 by combining it with oxygen. Okay, so you no longer have C and O by themselves. You now have CO and CO2, which are different, obviously, to O and C. And that's the difference between a chemical and physical change. Okay? Identify which of the following reactions is a physical change and which is a chemical change. Justify your choice. Okay, so you've got dot, square, dot, plus 2 circles gives you circle, square, circle, and 2 dots. And then you've got square, circle, plus triangle, dot, goes to circle, square, and triangle, dot. Okay? So A is a chemical change, while B is a physical change. In A, the arrangement of components is changed, indicating a chemical change. So what that means is, essentially, you've got these dots and these circles, and you see they're rearranged now. These lines connecting them are all different. So you've changed the chemicals, essentially, into new chemicals on this side. So it's a chemical change. Now in B, the composition of chemicals is unchanged, indicating a physical change. So you can see the triangle and the dot are still present. Okay, so these two are still present. But the square and the circle have just been flipped around. So they're still exactly the same thing, just you've gone from here to here. Okay, so you've just done this. So obviously they're the same substance. So nothing's happened. So it must be a physical change. Maybe, it became a gas, or maybe it became liquid, stuff like that. So you can see that's how we sort of diagrammatically represent a chemical and physical change. So the main indication that a chemical change has occurred is the production of a new substance. Identify 3 observations that would indicate that this has occurred. Okay, so what are the 3 ways to know a chemical change has happened? You've got a permanent color change. So the color has gone from one to another. So for instance, silver chloride turns into silver and chlorine. One is black, one is white. That's pretty obvious that the color has changed. There's a gas produced. Now we're going to go through a question on that, and we're going to come back to what that actually means and how do we be a little bit more rigorous with this particular criteria. A precipitate forms from 2 liquids. So you pour 2 liquids together and you get a nice solid all of a sudden. A solid disappears. Again, there's a bit different here as long as, if you're dissolving it in liquid. There is a subtle difference here with a physical change. And heat and light are produced or absorbed. Okay, so those are some common ways of knowing that a chemical change has occurred. Okay, explain the difference between chemical and physical change with respect to the particles within the system. Okay, now we're going to look at a more physical, or try and explain what is actually happening physically inside each of these systems. Well, in a physical change, the bonds between the particles are being influenced. So the bonds between particles are the ones that are being changed. The particles themselves remain unchanged throughout the process. So the particles are happy to just move around. Your reaction will just sort of just shift them around a little bit or give them more space to move, something like that. In a chemical change, the bonds within the particles are separated and the new particles are formed from the same components. So the particles themselves are broken up into their components and put back together in a different way, and that's a chemical change. Okay? So an indicator to detect chemical changes is the production of a gas. Explain why this may not be a good criterion and propose a more suitable test. Okay, so now we're going to talk about this gas thing that I've been going on and on about in this whole lesson. So why is it not a good criteria or criterion to use when we're trying to figure out if it's a chemical or physical change? The production of a gas can occur in some physical changes as well as in chemical changes. Okay? Now you're thinking, oh, well, give me an example because I don't understand what you're talking about. So if I boil water, I'm actually producing a gas, aren't I? I'm turning liquid water into gaseous water. Okay? But I know that's a physical change, but I just said that chemical changes can often involve the production of a gas. So now we're in trouble, right? There's ambiguity, essentially, in this question. So obviously it's ambiguous, and thus a better criterion should be used. A better criterion that we could use is the evolution of a gas with different chemical properties to the original substance. Okay? So it has to have different properties to the substance that you started with. So obviously steam has the same chemical properties as water, but hydrogen obviously has different properties to hydrochloric acid and zinc. So you can see that that's a much better, much more rigorous definition or criteria to use, rather than just saying, look, any gas produced means it's a chemical change. Okay? So that concludes today's lesson on physical and chemical changes. We looked at what a physical change is, what a chemical change is, and how do we identify both. Okay? So I look forward to seeing you at our next lesson.